Welcome back, Harmony Science Academy students. We're going to go ahead and get into today's lesson. Like always, pencil, your notebook, and your Chromebook, okay? I see a lot of you guys putting paper and pencil together. You guys look awesome. You guys look uh, like real math individuals, strong math students. I know you guys feel it, so keep up the good work. Um, not that calculators aren't valuable, they're incredibly valuable, but so is yourself, your brain. And honestly, it's an honor to see you guys doing what you're doing on paper and pencil. Okay? So enjoy the rest of this semester. Next semester, we do use it, but don't forget, you guys are a lot stronger than you probably thought otherwise. And it's, again, really awesome to see that. Okay? What you want to look up, pause here, is you want to look up a mathematical word problem. Okay? What is the definition for that? And I think since we spent a couple of days on systems of equation, look up why use system of equations, okay? Or systems of equation. Um, really, you might miss the reason why, right? That question of when do we use that in the real world? Well, it does apply big time with these systems. And the cool thing is today we get to prove it, okay? So we have, as the title shows, solving systems in word problems. Okay, and basically you got to solve. Okay, the objective here is to solve. And this is one of those rare cases where the title solve systems in word problems is the same as the objective. Okay, so let's go and get into it. Right. So of course, the first glance, you guys are probably a little intimidated by this. I am always, right? It takes reading and processing. What if I get it wrong after all that work? Hang tight. Okay, you guys are solid with this skill set, so you guys are going to be fine. Okay. All right. So let's go ahead and look at number 8. Okay. You guys will have 5 easy, 5 medium, 5 tough ones, and this one's right in the middle. So this one reads, the school that Emily goes to is selling tickets to the annual dance competition. On the first day of ticket sales, the school sold 4 adult tickets and 11 child tickets for a total of $91. The school took in $28 on the second day by selling 2 adult tickets and 2 child tickets. Find the price of an adult ticket and the price of a child ticket. Okay? Now this is not only real world application with this problem, but a lot of situations where there's money and different stuff was sold. How do you process what individual things cost? Some of you guys will go into your own businesses and you'll have all sorts of inventory. You might buy inventory from somewhere else. Who knows? You might want to get the breakdown. Hey, well, how much did I ultimately pay for this or that? This is pretty good stuff, okay? So let's go ahead and get into this one. So the first thing we'll do here is identify the unknowns, right? Find the price of an adult, right? We had a fundraiser. We're business people. Hey, we got to find out what's selling, what's not selling, how much. Okay. Find the price of an adult ticket and the price of a child ticket. So I don't know that, and I don't know this, right? So again, we're running our business. We're trying to do, and we're using real math. Okay. So now we gotta turn real life into math, so we can produce the math and then apply it back to life, right? On the first day of ticket sales, the school sold 4 adult tickets. Okay, so right, 4 times whatever the cost is, and 11 child tickets, and we made $91. Okay. The school took in $28 on the second day by selling 2 adult tickets and 2 child tickets. So I could write it out exactly as is. I'm going to cheat the system here and kind of tweak things because I think I've got a good idea of what's happening here, right? So $28 is the total. And what else do we have? 2 adult tickets. So this part, labeling this, is going to make my life completely easier. Rather than trying to remember, it's not going to happen. It gets confusing, okay? So anyways, 2 adult tickets and 2 child tickets. Okay. Now I've got a real life problem. The question is, what approach do I take? All right. So if you said substitution, you're correct. If you said elimination, you're correct. Right? It's now a preference thing, right? You guys have tools in your toolbox, so you decide what you like working with. Okay. What I'm gonna go ahead and do is I'm gonna multiply this bottom equation by -2. Okay. So that I can eliminate. Okay. I think most of us like elimination, so when you have a chance, jump at it. Okay. And I'm sure you guys are like hawks watching for me to make a mistake, which is awesome, because the whole point is for you guys to get smarter than the old guy, right? You guys got to pass the knowledge on, so keep your eyes open, okay? All right, I'm gonna go ahead and add these equations, and I get 7y equals 35, and y equals 35. Okay. Oops. You guys were on top of that, I'm sure, right? Let's see here. Okay. So we'll address this in a little bit. Let's just get the math done. So this is really the hard part. Now the fun part is plugging it in. I like this original equation, so I'm going to go 2x plus 2y equals $28. That's 2x plus 10. Subtracted, I get 2x equals 18, and x equals 9. Okay, so mathematically I'm done, but now I've got to go back into the real world and look at what the heck, find the price of an adult ticket and the price of a child ticket. So x is adult, right? So adult, we'll say big T for ticket, adult ticket equals $9. And what do they call these? Children, child? Okay, child. Child ticket equals $5. Okay? So, probably should have put them closer together, but this is the ending statement. All right, guys, appreciate your time. We'll catch you in class. Keep up the good work.